Good morning, students. After discussion of various types of homogeneous and heterogeneous mixtures, now the next topic is how we can separate the contents of a mixture, because it is very important to get the substance in pure form. The impurities are to be removed, and if a particular substance exists in the form of a mixture in nature, then it is very important to obtain it in pure form. So let us discuss now what are the methods or techniques used to separate mixtures. Various methods by which we can separate mixtures actually are based on physical properties of the components present in the mixtures, and as we have already discussed that this is the basic difference between a compound and a mixture, that we can separate components of mixture by any physical method, whereas to separate a compound we need to do some chemical treatment and all. So physical methods are actually based on certain physical properties of the components present in the mixture, like their density, solubility, size of particles, and boiling point, etc. And commonly used methods you have already done in lower classes, like if two solid mixtures, if two substances in solid state are mixed together and the particles are of large size, then hand picking can be used, sieving can also be used, filtration can be done to separate insoluble component from a liquid mixture, and sedimentation can be done for colloidal mixtures, for suspensions in which the particles settle down. Loading can be done to settle down suspended particles, and magnetic separation can be done if some magnetic impurities are present in a particular compound. So these common methods can be used, and other methods which we can use to separate mixtures we'll discuss now one by one. First of all is evaporation. Evaporation is a process in which a liquid converts into its vapors. So if we need to separate a solute which is non-volatile, means which does not vaporize on heating at the temperature, the solvent vaporizes. So volatile solvent can be separated by heating the mixture up to dryness, and as you can see in the figure, mixture is taken in a china dish and it is allowed to heat up to dryness. The water or the solvent get evaporate out, leaving behind solid residue in the china dish. And this process, the process of evaporation, is based on the principle that on heating a solution, volatile solvent evaporates out, whereas non-volatile solute remains behind as solid. Applications of evaporation are to obtain common salt from seawater or to obtain any soluble component from its solution. Next is sublimation. Sublimation is a process in which a solid substance directly gets converted into vapor without converting into liquid. So if a substance is sublimable, or a volatile solid which directly gets sublime on heating, can be separated from the other impurities which do not sublime. So in this method, mixture is taken on a china dish and it is covered with the help of an inverted funnel, as you can see in the diagram. And the funnel is the mouth of the funnel, or you can say the tube of the funnel, is closed by the help of a cotton plug to remove the escaping of, or to prevent the escaping of vapors of ammonium chloride. So when we heat the mixture, ammonium chloride, being sublimable solid, gets converted into vapors, leaving behind the other non-sublimable salt in the china dish. And when the vapors of ammonium chloride reaches the walls of the funnel where the temperature is lowered, they get deposited over there in the form of solid ammonium chloride. So in this way, two solid substances can be separated from their mixture if one is sublimable and other is not. The principle of sublimation is on heating a mixture of two different solids, The solid which is sublimable or volatile and easily get converted into vapor gets separated out in the form of pure vapors, leaving behind non-sublimable solid. And the applications of this method are: firstly, we can separate ammonium chloride from common salt, and we can also separate pure naphthalene, camphor, iodine from non-volatile impurities. If these compounds are present with some impurities and if we need to separate them in pure form, then sublimation method is applied over there. Centrifugation is a method in which a colloidal mixture is rotated at a high speed in a centrifuging machine, and during rotation the lighter particles stay at top whereas the heavier particles are forced to bottom. So the colloidal mixtures get separated out in the components on rotating at a fast speed. Here we can see how this separation takes place. In this video you can see that water having mud particles suspended in colloidal form are taken in test tubes, and in another test tubes milk is taken into other test tubes. Small amount of milk solution is transferred there, and these 4 test tubes are placed in a centrifuging machine, the way you can see here. And now when this mixtures are rotated at high speed, then due to centrifugal force the particles of different density get separate out. We'll see now what will be the change you'll observe. Here we can see that the fine mud particles which were earlier suspended in water are now settled down. As they are heavier, so they will settle down at the bottom. And here also you can see that milk solids are separated out, leaving behind the clear water. So in this way, any suspended impurities in the form of colloidal mixture can be separated out by the process of centrifugation. The principle of centrifugation is that when a mixture is rotated at high speed, heavier particles are forced to bottom and lighter particles stay at top. Applications of centrifugation are: first, to separate butter from cream in dairies. At home also we are separating butter from or you can say we are separating butter from milk as well. To separate components of blood and urine in diagnostic laboratories. As we know that blood is a kind of colloidal mixture, so for various diagnostic tests the various components of blood are separated by this process of centrifugation. And also in a spinning tank of washing machine, the water is separated out from clothes by using the spinning tank. Next is to separate a mixture of 2 immiscible liquids. As we know that immiscible liquids are the liquids which do not get mixed with each other, and liquids, when they do not mix, then they will automatically separate out in 2 layers on the basis of densities. For example, you can see when you mix oil and water together, the oil starts floating over water as these 2 liquids are immiscible in nature. So when such a mixture is allowed to stand in a device, you can see here in the diagram, known as separating funnel. So this separating funnel has a stop cock or tap which can be opened to separate one bottom layer and then second time the upper layer. So in this way these 2 liquids can be separated out by the or on the basis of density of the liquids, where the heavier liquid will form the bottom layer and lighter liquid will float over the heavier one. And the principle of this method of separation is when a mixture of two immiscible liquids is allowed to stand, the liquid components separate out on the basis of difference in their density. The substance or the liquid with higher density will form bottom layer, and the liquid with lower density will form upper layer. As you can see in the figure, kerosene oil, which is lighter or lower in density, will form upper layer and water will form lower layer. Applications of separating funnels. The method in which we are using separating funnel are to separate kerosene and water, to separate oil, any type of oil from water, and to separate lighter slag from molten iron in blast furnace. As you can see here, the blast furnace is actually you can say a metallurgical device in which we are extracting iron from the iron ore. And here in this process you can see during extraction the bottom of the blast furnace has two outlets, one for molten slag, which is slag is actually impurity present with iron ore, so which are separated out in the form of above layer or top layer, and molten iron being heavier than the impurities will remain in the bottom layer in molten form. So this molten iron gets separated out from the bottom layer or bottom outlet, and from upper outlet molten slag is getting separated. So in this way impurities can be removed from iron in blast furnace. Next method to separate colored components of any pigment or dye. This method used is known as chromatography. The word chrome means color. So this method was actually first used to separate components of a colored substance. That is why it is named as chromatography. But nowadays it is used for many different type of mixtures. And in this method actually various color components of a natural or synthetic dye get separated on a chromatographic paper at different heights, and the pattern obtained is called a chromatograph. Here you can see how this activity is performed. You have to take a filter paper, normal or a chromatographic paper, on which draw a line with the help of a pencil, and then at the center of that line just put a drop of ink or any other color which you want to get separate out, and now dip this or place this filter paper in a funnel or in a cylinder or a glass containing small amount of water, but the level of water must be below the mark, and now leave it for some time. After a few hours you will observe that water starts rising on this filter paper, and you will see a pattern of different colors at different heights. Here we can see how this pattern is observed. When water rises, actually the different components which are present in a particular dye, actually a dye is made up of variety of colors. So all of these colored substances have different solubility in water. So on the basis of solubility they will dissolve in water and they will move further, and the colored component which has greater solubility, higher solubility in water will reach up to the greater heights. So in this way, on the basis of solubility, the colors are separated at different heights. And the basic principle of this technique is when a mixture of colored substances in a suitable solvent is allowed to rise on a chromatographic paper, the components get separate out due to difference in solubility in the same solvent. In this way, the chromatograph is observed various colors at different heights. And this method can be applied to separate pigments from flowers, to separate colors of a natural or synthetic dye. Next method is distillation. Distillation is a method which is used to separate a liquid mixture having miscible liquids. Means miscible liquids which are thoroughly mixed with each other, and do not form layers cannot be separated by any other method. And the distillation method is based on the difference in boiling point of the liquids. Actually, when liquids have actually each liquid has a fixed boiling point, and if two or more liquids are mixed in a mixture and they have a sufficient difference in boiling points, then they will boil separately. Means when we start heating this kind of mixture, first the liquid will lower boiling point will start boiling and we can separate it out. So the liquids which are to be separated out by this method must follow two conditions. Firstly, the difference in boiling point should be greater than 25 Kelvin and the liquid should not decompose during the process. Means mixture में ऐसा liquid नहीं होना चाहिए कोई भी जो उस boiling point temperature पर decompose हो जाए. So this is how the process is carried out. You can see here, this is a round bottom flask known as distillation flask, in which the mixture is taken and it is closed with the help of a cork, a fixed thermometer within, and when we heat up this mixture, suppose the mixture contains two different liquids having a sufficient difference in boiling point, then the component of mixture having lower boiling point will boil first and the vapors will pass through the condenser, and condenser has cold water flowing through it, hence the liquid will get condensed into the vapors will get condensed into liquid again and they will fall in the container which is taken at the outlet of this condenser. And now the temperature, if we'll observe, it will remain constant till one particular liquid the entire liquid will boil off, and now after that the temperature will start rising again, and as soon as the boiling point of second liquid will reach, now the temperature will again become constant and the second liquid will start boiling, which can be separated in another container. So here the diagram, you can see it is showing the distillation of water, how distilled water is obtained, leaving behind all other impurities which are actually not boiling with water. So this type of water which is obtained by distillation is called distilled water. So the simple distillation process is actually based on the principle when a liquid mixture is allowed to boil, the liquid with lower boiling point separates out in the form of vapor, and which is further when passed through the condenser, it will get converted into pure liquid. And this is actually based on the difference in boiling point. When there is a sufficient difference in boiling point, only one liquid boils. The application of simple distillations are to separate a mixture of acetone and water. As you can see here in this diagram, mixture of acetone and water when boiled in a distillation flask, then around 56 degrees Celsius acetone gets start boiling and temperature remains constant till the whole acetone will get vaporized, which can be separated in the beaker, and after that the temperature will start rising further till the boiling point of water will reach. As acetone has boiling point 56 degrees Celsius and water has boiling point 100 degrees Celsius. So due to that sufficient difference in boiling point, we can separate these two pure liquids by the process of distillation. We can also separate a mixture of ether and water. We can also separate a mixture of methanol, that is a kind of alcohol, and water, because these liquids have a sufficient difference in boiling point. But if the liquids present in a liquid mixture have a very small difference in their boiling point, which is lesser than 25 Kelvin, then the simple distillation cannot be used, because when liquids have approximately similar boiling points, then these liquids start boiling together at the boiling temperature and it will be not possible to separate them. So in that case, another method is used which is known as fractional distillation. This is otherwise similar to the simple distillation, except one glass tube which is used here, known as fractionating column, which contains glass beads to provide surface for cooling vapors. Here you can see the diagram. This fractionating column is a cylindrical glass tube which contains glass beads. Actually, when mixture having miscible liquids which have very less difference in boiling point is boiled in distillation flask, the mixture actually boils as a whole. In that case, when these vapors are passed through fractionating column, then these beads present in this column provide a surface area to cool down these vapors. So the liquid having high boiling point will condense back and fall again in the distillation flask, and the liquid with lower boiling point will pass through the delivery tube and condenser and can be separated as a pure liquid. The application of this method, that we can separate petroleum products like petrol, diesel, kerosene from crude oil or petroleum, because these liquids have very less difference in boiling point, and also we can separate various gases from air. Let us now see how air can be separated out into various components by fractional distillation. Firstly, the air is filtered out to remove impurities, and then this pure air is compressed under high pressure, and then it is cooled by passing through a cold chamber, and then after cooling this compressed air, carbon dioxide gets separated out as in the form of dry ice, and then this cooled liquid air is passed through another chamber, or you can say it's subjected to fractional distillation column, where the nitrogen gas is you can say separated out first, as it has the lowest boiling point, minus 195 degrees Celsius, followed by argon, and then at last liquid oxygen is obtained at minus 183 degrees Celsius. So in this way, by applying the method of fractional distillation, various gases from air can be separated out. I hope all the separation techniques are clear to you all. Thank you and have a nice day.